Welcome to the third video in this cameras and resolution tutorial series. You might have noticed that the title and/or thumbnail suggest it is the advanced video. But what do I mean by that? Mostly it means I'm going to move very quickly. I'm not going to spend a lot of time explaining each line of code and what every function does, and I'm definitely not going to do the thing where I run the game knowing it won't work. Well, maybe I'll do it a couple of times, but most of the time stuff will work as expected when I run it. Regardless, to get the most out of this video, you should be comfortable with macros, functions, methods, structs, and constructors, or at the very least be willing to pause the video and go do some research when I do something you don't understand. I'll also be doing a number of things specifically in my style. Just like artists, programmers often have a distinct style, and that style can change over the years. Just because this is how I do it now doesn't mean I'll do it exactly like this in a few years. And the older this video gets, the more likely I am to hate the way I do things here. So ideally, you've arrived at this video not to just copy and paste everything I do exactly as I do it, which is fine, I guess, but to learn some concepts and be willing to implement them in a way that you are comfortable with. I will do my best to call out things I'm currently experimenting with, but you should be comfortable with the idea that there's never going to be a tutorial that does everything you need written in a way that works perfectly for your project. To be an advanced GameMaker user is to be able to understand general concepts and processes and then apply them to fit your needs. So if you're ready, let's get to it. Before we go adding more features and enhancing this code, I want to clean things up a little bit. If I were actually coding it for myself in my own project, I wouldn't have coded it like this, specifically because I would have brought in my view macros script before I wrote a single line of code. Let me drag that in and give you a tour. As usual, this is available in my Helpful Scripts GitHub repository, and there's a link in the description. This macro set is just a bunch of shortcuts to the common view and camera functions. Using these macros over the functions makes my code so much easier to read and work with, as I hope you'll recognize. Now I can refactor my code to use them. There isn't much to explain here. Hopefully you understand what macros are and how they work, so I'm just going to quickly rip through my camera object and refactor what I can. I'd move my base width and base height values into this macro set as well, so let me do that and do a find and replace real quick. Now we are ready to start enhancing this system a bit. The first thing that bugs me is that the camera has to rocket over to the player right at the start of the room. So unless the player starts every room in the top left corner, this is no good. We want the camera to start snapped to the player. So let's write a little method to do that and call it in the room start event. Perfect. We'll enhance this a bit when we can support dynamic targets, which we'll do right now. So you don't necessarily always want your camera following object player. You may want to follow other objects, or maybe even just look at a specific position in the room. So let's set that up. We'll do this with a new variable, current target. And we'll add a method to control that variable, set target. So here's the cool thing. Target doesn't need to be an instance. We can just as easily support sending a struct that has an X and a Y property. So in snap to target and the end step event, we need to change how we are checking if the current target is valid or not. Since we need it in both places, let's make this another method. If our current target is not a struct and the instance exists, it's valid. Or if it is a struct, then it's valid. We'll call this at the top of snap to target and the end step event, as well as replace any object player references with current target. To test this, let's add some code to the player object to pick a random position in the room to focus the camera on when I press spacebar. And when I release the spacebar, let's set it back to focus on him. And why not? Let's snap it when we refocus on him. Let's run the game. And now when I press spacebar, it changes the camera to target to a random position in the room. And when I let go, it snaps back to the player instantly. This is a pretty common thing that happens in games, like when you hit a switch that opens a door. Our camera's create event is getting a bit out of hand, and it's only going to get worse. so I think it's time to do a bit of cleanup. As I mentioned at the start of the video, some of what I do is going to be purely stylistic choices. You are certainly free to just leave everything in the create event just as I have it now. But let me show you what I've been doing in some of my more recent projects to help organize things. First, let's put Object Camera in a folder. I'm going to create two script assets, one to hold window-related methods, which we'll have a few more of here in a bit, and one to hold our view methods. I name them with double underscores and the object name to keep things organized and to make sure I don't accidentally call them in other objects. These scripts will get called exactly once in the create event of our camera object right at the top. One bonus feature of doing things this way that I really like is how if I press Ctrl T and type Object Camera, it creates this sort of pseudo tree structure in the list there. Kind of cool, especially in more complicated objects that have a lot of these scripts. Okay, let's move our target stuff into the view method script. And now we'll continue cleaning up this create event. The next block of code is just calculating the max window scale, so let's make that a window function, and then call that in the create event to set our initial window scale. The next few lines are just initializing everything about the window. Again, this may be overkill, but I really like to write self-commenting code. Like I could do this. Initializes window size, resize app surface, and sets GUI, whatever, right? But I prefer it if the code described itself. So I'm going to throw this in a function called initWindow, throw it in the window method scripts, and call it here. Again, you might think this is overkill, and maybe I'll think it's overkill in the very near future. It's purely a style choice, so feel free to just not do this part if you don't want to. I'm going to apply this same logic to every event. I'll ask myself, what is this block of code doing? And then I'll write a method with a name that describes that action, cut and paste the code into a method, and then call the method in the event. I'm going to rip through this real fast, and then we'll continue. I'll say it one more time. This may feel like overkill, but there's something very warm and fuzzy about being able to go to my room start event and read in plain English what is happening. I'm initializing the view and then snapping to the target. I can see so clearly what this object is doing in every single event, and that just feels nice. As this object gets even more complicated, we'll be glad we've taken the time to do this. Alright, that was a bit of a detour, but now we're back to adding cool features to our camera. Next up is Screen Shake. For this, we're going to use my Shake class that's in my Helpful Scripts GitHub. If you want it, you know where to find it. This is my go-to method for shaking the camera. I think it's simple to implement, easy to control, and looks really nice. Let's drop the Shake script into my scripts folder, and I can see right at the top that there are two required scripts, Approach and Sine Oscillate. Let's bring those in as well. Don't worry about the inner workings of Approach and Sine Oscillate, but let's crack Shake open and take a look. So the Shake constructor has two functions, start and update, as well as two properties that give us the current shake offset, X and Y. Let me show you how easy this is to use. In the create event of Object Camera, let's just new up a shake. Then let's add a step event so we can update the shake. Now, we always want to apply our screen shake after the camera has positioned itself. So the best place for us to do this is in Camera Set View Position Clamped. Before we set the view position, we'll just add the shakes X and Y to our target. Now, over in the player, let's shake the camera when we press S. So shake.start takes up to 4 arguments: the direction of the shake, the amplitude, the fall off, and the frequency. Direction will control the angle the screen is shaking at. We'll start with down, 270. This would be great for like a ground slam or a falling boulder hitting the ground. The amplitude is how large the shake is in pixels. The larger this number, the more extreme the shake. Let's start with 10. The fall off is how much the amplitude is reduced each step. So 0.25 means that we'll lose 1 full pixel of amplitude every 4 frames. meaning it will take 40 frames, or just over half a second, for the shake to fade away. The last argument is frequency. This is how rapidly or violently the shake happens. It is a bit weird though, as it's based on actual seconds and not steps. If you set this to 1, it will take a full second to complete one shake, down to up, back to down. The default is 0.1 seconds, and that's what I'm going to leave it at. Now, let's run the game and press S. I like it. And check it out. Shaking even works, or we're looking at a different target. One thing to note, since we apply the shake offset after we clamp the camera to the room, the shake can show the area outside of the room. If this bugs you, you could add a buffer to the room clamping so that it doesn't clamp right to the edge of the room, but instead leaves a few pixels to allow for some shaking. But in most cases, it's not going to be a big deal. Next, let's mess with zooming. Zooming is pretty unusual in pixel art games, but it does happen, and it's super common in HD and hand-drawn games. So let me show you how to do it. As always, there are a lot of ways to do zooming. One way is to keep track of a single zoom value and resize your view by taking your base size and dividing by that zoom level. But this makes it difficult to jump to a specific width or height for your zoom. For example, if you wanted to zoom out to show the whole width of the current room, you'd have to do some math to determine what you'd need to divide your base width by to get the room width. Doable, sure, but a bit more cumbersome. Instead, we are going to build a system that keeps track of a target width and will increase it to zoom out and decrease it to zoom in. Then we can build in some helpful functions like setting it to a specific width or adjusting it relatively. Back in the create event of Object Camera, I'm going to add a new zoom struct with 6 properties: width, height, speed, ink, min width, and max width. But we aren't done with this struct just yet. I'm going to add some functions right into it that will control how the zoom behaves. We could write them in the relevant events first and then refactor them to move them in here, but I already know I'm going to do that, so let's just jump right to the correct answer for the sake of brevity. First, let's add a function for setting the zoom. It needs to take a target width, and then we'll set the height based on our game's aspect ratio. I have macros for aspect ratios for all of our rendering elements: base, view, app surface, GUI, but they should always all be the same, so it doesn't really matter which one we use here. Next, I'm going to write a function to allow us to change the zoom a little bit with the mouse wheel. Now we just need a function for applying the zoom to the current view. The bulk of this code is to fix an issue that trips up many people trying to implement zooming for their first time. When you zoom a camera in real life, we expect that the thing in the center of the camera stays in the center, but unfortunately, that's not how GameMaker cameras work. When we zoom in, we just make the view smaller, which pushes whatever is in the center down and to the right of the center. We want our camera to behave like a real camera, so we capture the position in the room that is the current center, resize our view, and then put our camera back into place so that the center point doesn't move. Try commenting out that last line there and see what happens. It's super important we do this. Alright, now we need to call these functions. In the step event, we'll call zoom.change, and in the end step event, we'll call zoom.apply. Let's see this in action. As we zoom in and out, keep an eye in that top left corner, specifically that view 0 multiplier. If your game is pixel art and that is ever not a whole number, you've introduced pixel distortion, and you really shouldn't let your game sit at that zoom level for very long. It might be fine depending on your art style, but the distortion is there, and there really isn't much you can do about it easily if it looks bad. However, if your game isn't pixel art, this should look good at pretty much every zoom level. Real quick, let's make sure our min and max values work. Oh, yeah, so this is working, but we found a problem. However, This isn't really a problem with our zooming code. It's a problem with our room clamping code. We'll take care of that next, but before we do, you might be asking yourself a question. So let's go back to the create event and pull up our shake constructor next to our zoom constructor. These look pretty similar, don't they? Not that they do the same thing, but that they are both structs with properties and functions, and we use them in a very similar manner throughout the code. So why does shake get to be a proud constructor while zoom is left being a pleb struct literal? Is there any real reason behind that? Honestly, no. You could 100% turn this into a little constructor that you knew up in the create event of the camera. No problem. But it's really only useful in this object. Shake is much more generic. I can shake a camera, shake an object, shake a button in the UI. It's pretty versatile. Zoom just changes the camera, and you can really only ever have one at a time. So I could make it a constructor, but it wouldn't really do anything for us. So I'll be keeping it as a struct literal. All right, back to that problem we just saw. It's pretty unlikely that you'll give your player the ability to zoom out larger than the current room. So this exact problem is a bit weird. But what's much more likely is that you drop the player into a room that just happens to be smaller than the view. This happens all the time in RPGs. You enter some hut and it's just a single small room. The camera doesn't move to follow the player, and there's just a black border around the whole area. We need to account for this possibility in our room clamping code. Fortunately, we have a function specifically for that, so let's crack it open. So after we get our clamped position, we want to make a couple of checks. If our view is wider than the room, we want to center the view horizontally on the center of the room. And we do the same check for the room height. Let's run that and see what it looks like. So there's a tiny hitch as we cross that boundary because our camera is changing what it is centering on. Again, what we are doing here is super unusual, and if you want to allow your camera to zoom all the way out to show the whole room, you probably shouldn't be clamping to the room at all. Try commenting out the clamping code entirely and messing with zooming in and out. It'll fix the issue. But we are going to work under the assumption that you aren't letting the player zoom all the way out, and you just want the view to behave normally when the room you've entered is too small. So let's add a couple of small rooms, and we can test it there. There we go. That looks much better. As we move, the camera doesn't follow us unless we zoom so far in that it fits in the room. And, yep, we can still shake the camera. The last two features I want to build are for toggling full screen and cycling the window size. We'll start with full screen swapping. The first step is to turn off the ability for the player to use the operating system's default keyboard shortcut to change between full screen and windowed mode. Alt+Enter on Windows. Let's make sure that's disabled as we want the game to use our code for toggling full screen on and off. Now, let's jump over to the step event of Object Camera and write some code. We'll listen for F4 being pressed to toggle full screen. That's it, right? We're done? Not quite. Since our project is using subpixels right now, when we resize the game window, we want to take advantage of that extra resolution, so we need to resize our app surface. Likewise, when we come back from full screen, we need to reduce the app surface size so we aren't rendering at a higher resolution than is necessary. We either want to use the window scale or the maximum scale depending on if we are full screen or not, so we can just use a quick ternary statement and store the appropriate scale in a var. Then we just resize the app surface based on the scale. And when we run the game and press F4, we swap to full screen. Pressing it again swaps us out. But hold on, watch our view scale value in the top left. When we switch between full screen and windowed mode, it's not changing. It stays 5x. And look at our app surface dimensions, 1600 by 900, but the display says 1920 by 1080. What gives? The problem lies in our calculate max window scale function. This was written to calculate the max window scale in windowed mode, which, as I've said many times now, needs to account for the window header bar. It has to fit, or Windows is going to squish us. But in full screen, we don't need to worry about that. So let's add an argument to this function so we can tell it we don't need to account for the header bar. And then use that argument when we swap to full screen in the step event. Now when we run, we get the expected full 6x scaling and full 1080p application surface size. For the next feature, let's allow the player to change the window size. It's really annoying to force the player to use the maximum possible window size all of the time, but allowing them to resize the window with no restrictions means it may get sized in a way that doesn't look good. A common middle ground is to allow the player to pick the window scale they want to play in. A scale of 1 is the game's base resolution, and the player can pick any supported multiplier up to the maximum. But if your game is pixel art, the option should be restricted to whole numbers. This is pretty easy. We already have a window scale variable, we just give the player a button to change it. For now, we'll just set up F3 to cycle through all whole number scales for the given monitor. Back in the step event, we'll listen for F3. If we're in full screen, just exit. We don't want to do anything. Otherwise, we'll add 1 to our window scale and mod it against our max window scale plus 1. This will wrap the window scale value around when it exceeds the max value. But when it does wrap, it will wrap to 0, which doesn't make for a good window scale. So we'll make sure it's always at least 1. Then we just set the window size based on the current scale, center the window, and just like we did when swapping to full screen, we resize the app surface. Now when we run, we can press F3 to cycle through the different perfectly scaled window sizes. And at any time, press F4 to jump to full screen, and press F4 again to jump back. Last thing is to put these into functions to clean up my step event. Whew, okay. That was a lot, but you made it through. Now you should have a more than capable camera and window management system suitable for the vast majority of GameMaker projects. The last video in this series will venture into the really complicated topics. I'll talk about the GUI layer in a bit more detail, and we'll discuss the different methods for scaling your pixel art game to any resolution. Sort of. If you have questions, want to get help with GameMaker, or even just hang out with other GameMaker users and talk shop, I recommend joining the GameMaker Discord server. I put a link in the description. Thanks for watching, now go make something awesome.